into the how we use it then. This is our magic quadrant that looks at forecast value add versus demand variability, or another better way of looking at demand variability would be like a mean absolute percentage error, a MAPE. So at the bottom, from a left to right perspective, you have your forecast value add. And the way you go further to the right, you have higher forecast value add. And people haven't used it. Sometimes your forecast value add could be 1 or 2% better. And usually that midpoint is usually a negative, or a depending on your industry, depending on how good your process is, you're really going to set that midpoint. And I've seen some companies that midpoint is 0, where the left on the avoid forecasting and selective forecasting side, you have a negative forecast value add, versus the market forecast and collaborative forecast, you have a positive forecast value add. Other industries with some of the CP type of industry, you could have a 1 to 2% on the left-hand side, and then the 5 to 10% over on the right-hand side. So it really depends on your individual business and company. But from the left to right is your forecast value add. Top up and down is going to be your demand variability. It could be a coefficient of variation, or it could be if you're measuring your MAPE. Depending on the level of aggregation, I said once again, a lot of these things depending on your business. I'm not going to go too deep into that. Hopefully I'm going to give you the concepts, and you can apply it to your individual business case. But the other way I look at this model then is from the right to left is really how much do I touch it is what I'm looking at. And then from up to down, it's really who touches it, which is an internal or external type of, looking at the low is more of an internal touch, meaning my department, demand planners. At the high end is an external touch, where I'm looking for external feed input into the forecasting process. So from the left to right is really how much to touch it, and up and down is who touches it. And that's really the way I look at this chart. So what I'm doing is I'm looking at all my items, my items that we are currently forecasting, and I'm plotting on this graph, saying, okay, these have negative forecast value add, these are positive forecast value add, here's a high forecast error rate, here's a low forecast error, and I'm putting them in these quadrants to determine where they're going to fit in the different boxes. From here, I can then determine how to allocate my time, how to allocate the resources, and how I can look at these different segments of products and forecast and get more return on my time and investment into certain segments of my items from a forecasting perspective. Looking at each segment real quick then, the top one, I say avoid forecasting. These are items that have a low or negative forecast value add, and they have high variability, high forecast error. The next segment we look at is the ones that we do selective forecasting on. These are low touch type of items. They still have a low or negative forecast value add, but they generally have lower coefficient of variation, the lower demand variability. They're more predictable from a modeling standpoint. And there's one thing I should take one quick step backwards and let you know that when I'm looking at the forecast value add, I'm looking at it from a naive forecast. So I'm looking at it from not only the naive to a model. The model we use IKEA to do a lot of our models. It's a great system. It gives us the capability of doing the segmentation inside the system. It has some great modeling capability with its algorithms and models that it creates using different attributes. So when I'm measuring my forecast value add, I'm measuring it at it from a naive to really the causal or the consensus type of forecast line is where I'm measuring that forecast value add. So when I say that we have a negative forecast, that means despite as good as the modeling is, it's not adding value compared to just a naive forecast or just a baseline statistical forecast model that comes out of the system. So with that, I really have to determine how much time I want to put into it. These are highly predictable type of items. These are mature products. These are going to be your high volume, low mix type of bucket. And generally you have history with it that a a basic time series modeling, or even runway type planning with a moving average, you can just usually end up predicting going forward using these type of models. So I'm going to minimize my planner's workload on these and touch points and just use that model. I'm not going to put a lot of causal inputs, judgmental inputs, because I'm not adding value to the process here. What we've actually found, though, looking at a lot of companies, is this being the mature high runners, this is a lot of the company's revenue is in this bucket. And I've seen a lot of companies, I've worked for other companies that had proportionate amount of time demand planning spent was based on these were the biggest runners, the highest runners, the amount of revenue. You actually probably are going to be disproportionate. If this is 80% of your revenue, you're not going to spend 80% of your time on these items. Because what we found through that forecast value add and looking at this metric is you're not adding value. You can take that time and apply it to other items and get a better return and allow the system to generate the forecast for this. And that's why I say these are the low-touch items that you want to have. You don't want to spend proportionate to the amount of revenue to the amount of time on these items. The next one is a collaborative forecast. These one we are adding value to. This is on the positive forecast value add side. And it also has a lower forecast there as well. In the consumer products, this is a lot of mature items in this because we still have a lot of promotions that are run within the industry. So you do have promotions you need to add input to. But these are predictable promotions because we ran these promotions for the past 3 years. And we can tell that, through price elasticity models or different types of models that we know the impact of a promotion we're going to do. So we can predict those, but it's not baked in the normal type of statistical modeling that the system does. So we have to add some touch points. Generally, it's a lot of internal touch points. It's collaboration that's going to occur where we know that trade-off of what the statistical modeling from the systems versus the judgmental input from marketing versus just the art of the demand planner that has to be able to put these different pieces into the soup and kind of stir it out and get an accurate forecast, because through that process we found out they're adding value. So this is where I want to focus my team, the thing to examine a little closer at the individual item, the trade-offs between the planner's contribution to maximize the resource versus the marginal returns you may get. Because these, I'm going to look at the high value items because I may be able to get a 1 to 2% because I already have a low forecast error at this level. I may just be adding 1 or 2% forecast value add. For a commodity type item, it's not worth putting a lot of effort and a lot of my planner's time into, I said, a commodity type of item where I'm not going to get a huge forecast value add, a lot of return out of it. But a high value item, at Tempur-Sealy, we sell, mattresses, and on the Tempur-Pedic side, some of our mattresses are $5,000, $7,000 mattresses. You get a high value item like that, a 1% error, when we're a make-to, stock type of business, and we have to have the stock for a 48 hour to a customer at the end, it's important to get that 1 or 2% forecast value add for those type of items. So that's what I'm going to focus my planner's attention on, and really focus on maximize my growth with customer satisfaction on this area.